Welcome to another math lesson. In this video, we'll be solving a question on the topic circle theorem. And here's the question. In the following diagram, A, B, C, D, and E lie on the circumference of the circle center O. BD equals BE, angle CAD equals 18 degrees, and angle BEC equals 51 degrees. So here's the circle, and then the first part of the question is asking us find angle ADC, B angle BED, and C angle EBC. So let's first identify where we have the angle ADC. So here A, D, and then C. So we are talking about this entire angle here. And then when you look at the triangle ADC, it is a semicircle. So, and we know that an angle in a semicircle, it is equal to 90 degrees. Therefore, angle ADC will be equal to 90 degrees, an angle in the semicircle. And then B there, we have angle BED. Let's identify where we have BED. So here there's B, and then E, and then D. So this entire angle there. We have already been given a 51 degrees on the part of this angle, and then there's another part which is remaining there, which is we can name it angle CED. Angle CED. So this angle, it will be equal to the angle here as well as the angle there. Angles on the same segment. So these angles, this angle here, this angle here, this angle here, are subtended from the same segment. So even this angle here will be 18 degrees. Even here we also have 18 degrees. Angles on the same segment. So this is 18. And then now the entire angle itself, which is a BED, will be equal to 51 degrees and then plus 18 degrees. When we add these two, we get 1 plus 8, that is 9, and then 5 plus 1, that is 69 degrees. So 69 degrees is the angle BED. We can move on and solve the last part of the question, which is finding the angle EBC. So let's identify where EBC is. So you have E, B, and C there. So it is this entire angle here. So again, on this angle, we have already been given part of it, which is 18 degrees. So another part is remaining there. So how can we find this angle? We can name this part here, the remaining part, as DBE. So let's find DBE. When we see such a thing where you have two lines like that, it means that the length of BE and BD are the same. And if that is the case, it means that what you have is an isosceles triangle. Even in the question, it's saying that BD equals BE. So what you have, this entire triangle, BDE, it is an isosceles triangle. And we know that for an isosceles triangle, base angles are the same. So if this one is 69, this other angle is also 69. So DBE will be given by 180 degrees, and then subtract the two base angles, which is 69, and then we multiply this 69 degrees by 2. We have 180 degrees minus 8 there, and then 138 degrees. 180 minus 138 degrees will give us get there. So this one will be 2, and then 7 minus 3, you have a 4. 1 minus 1 is 0, so it's 42 degrees. So here we have 42 degrees. We can now add these two angles and then come up with the entire angle, which is EBC. So angle EBC will be given by 42 degrees and then plus 18 degrees. When we add these two, we have 2 plus that, it gives us 0, and then 4 plus 1, that is 5, and then 60 degrees. So the angle EBC, it is equal to 60 degrees. We have come to the end of the lesson, and I hope you enjoyed the lesson. And if you're watching me on TikTok, you can follow my page. And if you're watching me on YouTube, you can subscribe to my channel, and I'll see you in the next video.